So, hey guys, my name is Parth, and thanks for coming to my presentation. I'm currently a rising senior at Mission San Jose High School. So for my starter project, I created a motion alarm, and this was just to get my hands on with Arduino, try to figure out how its syntax works, because I've never worked with Arduino before. And for my main project, I made running glasses. So the problem I encountered in everyday life when I was running and training for track was that often you have to look down at your wearable device or your phone and you're trying to figure out if you're running properly or if your pace is correct, right? And this is very unsafe if you think about it, right? When you're running, if you hit a roadblock or something, when you're crossing the street, it becomes unsafe and it becomes very inefficient. So my project tried to solve this by giving you a heads-up display so you can keep your eyes on the road while being able to mention or look at all your statistics at once. I guess the best way to explain this would be pictures. So on the top right, you can see one of my first prototypes. So this was, so you guys might not be able to read it, but it says space, mileage, and altitude. And these are the three main variables that are displayed on the screen. And on the left, you can see this sort of in action. It's not very clear right now because the camera was shaking when it was night. But when you wear them, they're much more crisper and clearer, and they tend to be much bigger, the wordings. And on the bottom, that was my first modification milestone. So what I did there was, if you were connecting this to a laptop, so suppose you were in a car and you wanted to know your speed and you wanted to know your mileage and you wanted to track your route. So you're wearing the glasses in a car, you get everything on the heads-up display, and after you're done with your trip, you press a button and everything comes up on your laptop, your route, and other statistics that you need. So that's a simple demo, and in terms of how does this actually work, right? What did I actually do to make this? So the most important part of my project is probably the GPS module, and this allows me to get the exact position I am on the globe. It uses a process called trilateration, which takes a certain position on the Earth, and using different functions, it allows me to make functions or do whatever I want with this position, like get pace, get mileage, how much I ran, how much I changed in altitude, etc. My second part would be the display. So I use an OLED screen, which essentially gives me very bright and vibrant displays. And the law of reflection is just simply that the angle at which you hit a screen is the angle at which it reflects, to figure out exactly how I want it to come back to my right eye. So in terms of roadblocks I faced in this project or major challenges, one of the biggest challenge was figuring out exactly how I wanted to get the data. So the first way I did this was using an accelerometer, and an accelerometer essentially measures force in the x, y, and z axes. And the problem with this is if your accelerometer is tilted, that means in the x and y axes it's measuring the force due to gravity. But I only wanted the force that was being applied on it because I was running straight or backwards. So I sort of fixed this problem by using a GPS module because it was almost impossible to try to get that error to be insignificant. So I used the GPS module for that. In terms of what I've learned from this program, I learned one very important thing. I learned that you're often going to get really excited about stuff, really passionate about it. But the important thing is to make sure you're calm and you think everything through before you act upon it. Often you love something so much and you know it's going to work or you just think it's going to work because it's Arduino, and then you face a trivial roadblock which just blocks your path and you have to change your whole concept or etc. And yeah, that's my presentation. Thanks for listening. So any questions?
How does trilateration work?
So trilateration is essentially, as the name suggests, you need at least 3 satellites, and they all create probability spheres. And the important part is they're spheres, so they give you height too. And where these probability spheres intersect, the middle of that intersection, it creates as your position, or your current position, and that gives you longitude, latitude, and altitude.
So in the end, you were talking about what you learned and how sometimes you shouldn't get over enthusiastic about things and you might make mistakes. Was there a specific instance in which you learned that?
You guys might be wondering why I made the modification for a car when I was doing running classes. Well, the problem was that I did all this, I got all the code working, everything was working, and then I forgot that the Arduino has to continuously send data to the laptop. And if I unplug the Arduino, then all the data gets lost. So even though so I tried different things, right? I tried to store information on the Arduino, but the Arduino doesn't have enough space. And I don't think drawing a line between 2 points is really helpful. So I had to figure out, modify my whole concept, so I used it for cars, but I guess it works well for cars, so yeah.
Great.